Now let's consider applying the short truth table method to the example of an argument that was not invalid. So here I'm showing you the panel where we constructed the full truth table, and looking at that table we found that there were no rows in which the values of P, Q, and R would make the premises true and the conclusion false. And as you recall, on the basis of that, we determine that this argument is not invalid. So how would we apply the short method to this argument? We will start by constructing our argument that's Q and R. The second premise is P, and the conclusion is R. Okay. Again, we will assume that the argument is invalid. Now, obviously, because we did that previous example, we know better, but the method is to assume that the argument is invalid and assign the values true to the premises and false to the conclusion. And now we'll work back as we did before. And here's a good rule of thumb for you to consider. As you're assigning values, you could start with a complex expression, but if you do, then you make the job harder for you, because it's much easier to start with expressions that cannot be otherwise, like the other premise and the conclusion. So let's start with those. So if the conclusion is to be false, then R has to be assigned the value false, and we'll circle it to indicate that it cannot be otherwise. And we'll put that value elsewhere for R. Okay. Now, the value of the second premise, we have assumed that it's true. So to make it true, we'll assign P the value true. And it has to be assigned everywhere. So now we have P as true. Now let's consider the only other variable left, which is Q. So we have two possibilities. What happens if we assign Q true? Well, in that case, Q is true and R is false, so Q and R is false, but P has to be true, and true implies false is false, and that conflicts with our assumption. So Q cannot be true if our assumption is true. Okay, not true. So the other value Q could have is false, but now what happens when Q is false? Well, Q is false and R is false. False and false yields false. P is still true because it has to be because of the second premise. But now if P is true and Q and R yields false, then true implies false is false, which conflicts with our assumption about this. So now think about it. If Q cannot be true in order to make our assumption true, and Q cannot be false to make our assumption true, then it means that we don't have a situation where the assumption could ever be true. In other words, there are no values we could assign to P, Q, and R that make this assumption turn out true, which is another way of saying that there's no row in the truth table where the input values yield true premises and a false conclusion. So what we say about that is this argument is not invalid. Now, of course, this is exactly what we expected because we did the full truth table. But again, the beauty of the short method is that it allows you to basically ignore constructing rows that you don't need to interpret in light of the definition of validity, and so it saves some work. Now, when you have an argument that has 3 distinct variables, that means 8 rows. That's not a whole lot of work, but you will see very quickly the work mounts up as you introduce more variables. So, for instance, 4 variables is 16 rows, 5 is 32 rows, 6 variables is 64 rows. It gets big very quickly. And so having a shortcut method can be extremely useful as long as you keep in mind the basic method, all right? And so let's review it. First, you lay out the argument in a form that you can work with like this. You make the assumption that the argument is invalid, in which case you will assign true to the premises and false to the conclusion. and then you work backward from that assumption, filling in cases that can't be otherwise first, like R cannot be otherwise to yield a false conclusion, so we assign false. And I like to use a circle around a value I've assigned if that value cannot be otherwise. Why is that important? Well, it saves time. If a value cannot be otherwise, then there's no sense in trying out other possibilities. So consider R here, for instance. R cannot be anything other than false, or we don't get what we're after, which is to try to find values that make the assumption that the argument is invalid work out. So with those rules of thumb, you can often shorten the amount of work that you have to do to assess the validity of an argument.